So you online, please take over.
So welcome back. Yeah. Oh, I will go back to the virtual box. There's something which need to be fixed before we start. So I will ask you to basically do something very similar. What I mean, the first step, we will update the workshop materials, and we will run a command which fix some issue which is related to G extension here. So yeah, so let's start with this and other. I mean, there are some libraries which are missing. We need to install them, and this script will do everything in one step. So let's go to ODSE work there, code, workshop. Let's open the terminal as we did in the beginning of the first workshop. So run git pull to get fresh code. And yeah, if you go to Grass GIS training directory, there is a new file which is called fix grass sh. So you run the script. You run it by sh fix grass. So I will enlarge it and I will keep it there. So once more, you need to run git pull to get the fresh content, to update it. Then you go to Grass GIS training directory and you run the command sh space fix underscore grass dot sh. It will probably ask you for the password. So this the user password ODSE hashmark 2021. In my case, it will be quick. In your case, it will be a little bit slower. It should take like depends on your internet connection, because it will be downloading Ubuntu packages which are needed. So it can take a few minutes, 1-2 minutes, maybe more, depending on your internet connection. Please run now. And meanwhile, I will explain what is in the front of us, what is the content of this workshop, and yeah, and after 5 minutes, I think in 5 minutes you should be able to run the script. If you want to check the result, you will check it easily. Okay, I'm not sharing the screen. This is the problem. Thanks for letting me know. So yeah, I need to go to Zoom right here. Why it's so small here? No, I don't see here. Okay. Yeah, great. So share the screen. So I will explain it again because you haven't seen my screen. Thanks for pointing it out. So once more, it's nothing new for you. So I explain. Okay. So you go to ODSE workshop. You open the terminal. You run git pull to get fresh code. Then by the cd command, you go to the Grass GIS training directory, as I explained, and enlarge it. And by the sh command and fix grass, you call the script which installs some dependencies which are not in the virtual machine. That's important because I mean the most important tool or tool set which we will use, e.sentinel. Without this fix, you will be not able to install it. So this is really important for this workshop. So run this command And I mean, if you wait like 2 weeks, 3 weeks, hopefully the RC1 will be out, and then you will be able to install Grass on your operating system, Windows, Linux, Mac. These 3 platforms are supported. And I mean, this fix will be not needed, of course. This is just a fix which is related to this virtual machine. So it will take some time, as I explained, and the result you can check by this command. Or okay, you can test it now, but I mean, we will be describing, or I will describe it. I will describe it in few minutes. But basically, it's about installing extension which is called eSentinel. So if I go to the terminal and I run G extension with i.sentinel parameter, it will be installed. So without the fix, you will get the errors. Okay, but okay, let's keep it for the workshop. So please run the script and let's continue. Yeah, I was mentioning that I mean the parts which are covered in the first workshop. We will I mean the things or the parts which we skipped because there was not so much time, like how to set up a mask, or how to use how to perform some simple expressions using map algebra tool. We will use this functionality in this workshop, so this will be explained. So yeah, so next unit, or if you go at the beginning, you see that there are 2 parts. The first part is over, and the second part is, yes, what is waiting for us. So we should focus on multi-temporal EO data processing in Grass. So I will present the T modules, or when I was explaining that the Grass is a modular system, that it's like an environment from which you can run different tools. And I explained or I highlighted that I mean each tool in Grass has a prefix, and this prefix clearly explain you which I mean the kind of the data which will be used by the tool. R dot is for raster processing, V dot is for vector data processing, and T dot, what is the I mean important group of the modules for this workshop, is for temporal data processing, or working with a time series, or working with a space-time data set, or cubes, or whatever you can imagine. Okay. We will work with a Sentinel data. We created a sample data set because I mean it would be too much for this workshop to download Sentinel data from Sentinel C-Hub or other providers. It would take a long time. You would need like one scene is about one gigabyte. Speaking about level 2 products, so of course this will be skipped, but I will explain how to download data. But I mean, we prepared a sample data set which with prepared data, and I mean we a little bit okay, we remove the bands which will be not used for by our computation. So the zip file contains like 3 Sentinel scenes, but not full scenes. I mean, we kept only the bands which we will use. Otherwise, the sample data set would be too big. It would be like maybe 4 gigabytes. So we just we just removed what we will not use. So this is the reason why the sample data set is about like a 700 megabytes. Okay, so let's start. So the first information, or when we started to work with GRASS, you could see that GRASS offers a lot of tools. I go back to the GUI here. Basically, if I just remove the keyword, okay, I can see all tools which are provided by GRASS installation. And here, okay, if you count the tools, it would be like almost 500 different tools which are provided by the GRASS installation. Beside of the tools which are provided automatically, you can install like extensions. So it's called add-ons in GRASS. It's something like, it could be, yeah, some user contributions. As I mean, you are familiar probably with QGIS plugins, or I mean, if you are using Esri software, there are extensions. So GRASS add-ons is something similar. It's just it's the tools you can install into the GRASS. They are not part of official distribution, but you are free to install it. And of course, I mean, it's user contribution, so you can find really cool modules which are really working well, which are stable, mature, great. You can also find the tools which are outdated. There are no maintainers, and yeah, they could be broken because they were not updated to the latest GRASS version. So this is a little bit like this is different approach, in the sense that the tools, the GRASS modules, which are installed automatically, which are part of the core distribution, there is some quality check. We have automated tests. So every time we did as a developers, we did a change, the unit tests are performed, and the regression can be identified quite very quickly. And then I mean, what I want to tell is that there is a quality check, and there is the tools which are distributed in the core distribution should be really stable, mature, tested, and they should be ready to use. With add-ons, you can really find great tools. You can find outdated tools. Okay, so this is first important information, that there are really cool tools for GRASS, but sometimes you need to install them because they are not included. This is the case of the tool set, or the group of the tools which will be really like a heart of this workshop. The tool set is called I.Sentinel. It's a group of tools which were designed to work with Sentinel data. As you can see, there are plenty of tools. The first two are probably the most important, because you want to download data as the first step, and then you want to get the data you imported. You want to get data into the GRASS. So there is specialized module tool, iSentinel.download to download data, and second module, i.Sentinel import to import data. There are other cool, useful tools like mask module, which creates a cloud mask. Coverage is very useful tool. By the coverage, you can compute, if you have a defined area of interest, you can compute the coverage, or I mean, how the scene, how the sentinel scene, the tile, I mean, the percentage of the coverage. So I mean, your area of interest can be fully covered by the tile or partially, and you can compute how much, 50%, 25%. So you can easily determine which tiles you want to download, how to combine the tiles, how to then there are tools for creating mosaics. So you have tiles which are partially overlapping, and you can, for example, you can use t-raster mosaics module to create mosaics from the Spacetime dataset. So there are a lot of tools. You need just to find them. So be aware that, I mean, if you don't find in your Grass installation the tool you would like to use, take a look to add-ons, and it can happen that you will find a tool which helps you, which helps you to solve your problem. So first let's try to import the tool, the i.sentinel, and this is like it was important to run the bash script to fix some remaining issues related to this virtual box. And there is still, I discovered that in this virtual box there is still problem with this graphical user interface. So I will ask you to install it using G extension command. So how to do it? So you go to console, and in the console you type G extension. You see that in the console it's useful that if you start to type, Grass is trying to help you. So here is G extension command. You just run it. It opens dialog of G extension, and here you just write the name of the add-on you want to install. I mean, this is not interactive. You need to write it manually, but of course there is a graphical user interface to install extensions, so you can search by the keyword, and yeah, so you don't need to know which extension to install. You search by the keyword, then you can check the description of the module, and yeah, it should help you to find the add-on, the tool you are searching for. Okay, but okay, in our case, we know that we want to use i.sentinel extension, so we will just install it in this way. So once more, run G extension module tool, and here write i.sentinel and type run, and it should install the add-on. Please ignore the warning here. It's nothing. I mean, it will not harm. It's just the warning we can ignore. What is important, after installation, you type here i.sentinel. After fresh installation, I mean, the add-ons or the module are not in the history. So you need to write it manually, like a full name. But I mean, if you start Grass again, it will recognize that there are new add-ons and you will see them in console. But if you type manually i.sentinel.download and you type enter, you should get graphical user interface. Yeah, you are not getting because there are all parameters. This is strange. but you see that the tool is here. Maybe I will enlarge it, but you see that the tool is here, and here you see parameters. Computer is a little bit freezing, but okay, now it's back. This module we will not, or you can try to use it if you have. Maybe I will show, explain. I mean, to use it, you need to have user account. So if you have a user account at the Copernicus Open Access Hub, or I mean, this tool is also supporting downloading Sentinel scenes from Earth Explorer. So if you have account, you can try it. I will just explain, but really, if you have account, you can try it directly. So I will just explain the usage here. So I will maybe enlarge. This module has really a lot of parameters. So this is really like a quick showcase how to use it. But there are plenty of options, plenty of parameters you can set up. What is important before downloading? I mean, it's good to check your filter, because I mean, if you don't check, it can happen that you start downloading a lot of scenes, a lot of products. So as the first step, it's good to first check what is result of your query, of your filter. So this is done by L-flag, like a list. So by the L-flag, you are telling to the tool, don't download, just print the scenes which would be downloaded. Yeah, map is the parameter which defines the area of interest. So by default, it will search for all scenes which partially overlap your area of interest. Area of interest can be defined by this map, by this vector layer. So it takes map extent or layer extent, and this extent will be used as area of interest. It's optional argument. So in the case that you skip it, it will use current computational region as area of interest. So it will search for all Sentinel scenes which partially overlaps the current computational region. By product or product type, you can specify which product you want to download, either level 2A or level 1C, or other products, I mean, related to Sentinel-1, for example. So here you specify which kind of product you want to download. Settings is the most important. It's basically a text file which contains 2 lines. First line is the username, and the second line is the password. So here you will specify your username and user password. By default, it search like last 60 days. So in this example, in Greece, for the last 60 days, it was like 24 satellites available, 24 products available. Usually you want to specify the time window, right? So there's a start date, end date. You specify, probably you want to specify the cloud coverage, the maximum cloud coverage. So this is 5%, and maybe you want to sort products which are printed to the standard output. You want to order them by the date, not by the cloud, but by the cloud coverage, but by the date. So you can see that here, I mean, the first scene, which has the cloud coverage. I mean, the smaller than 5% is from the last from the end of April. Yeah. So, and there are plenty of options you can set up. This is just an example. So first you set up your filter. You can also define, I mean, whether you want to communicate with a Copernicus Open Access Hub or C-Hub, or you want to communicate with Earth Explorer. Yeah. So first you design your filter, and when you are satisfied with your filter, of course you can also filter by UUID. That's also possible. Well, Sentinel granule is a zip file which contains JPEG 2000 data files. So it just download the files which are offered by the provider. Yeah. So I will explain it. It's explained in other module, in other steps. Okay, so you download plenty of scenes, hundreds of scenes, and yeah, okay, download. Yeah, you set up the filter. Now we are satisfied. So you basically remove the L flag. The L flag is the module which avoids downloading, just prints the result of the filter to standard output. So you remove L flag, and of course you need to tell to the module where to download data. So by the output parameter, you define where the data will be downloaded. So in this case, these zip files will be stored in the directory which is defined by the output parameter. So this is about downloading data. If you are interested about Landsat products, there are similar tools like i.Landsat download, i.Landsat import, and other tools. Yeah. So now the next step, you download the data, which, I mean, it was already done for you. So let's check the input data. So in the zip file, which we extracted, you go inside geodata, and there is a directory with a Sentinel data, which is called T34. It's the tile which we used, and here we unzip it because from the safe or from Granula we removed the bands we don't use, because otherwise our sample data set would be big. But you don't need to do that. You can work, or you can import the data directly from the zip files. You just enter the directory where the zip files are stored. Yeah, in our case, we extracted the zip files because we modified the content, but normally you just basically this directory which you define here where to store the data, the same directory you pass to the next module to import, and this module will import all data which are located in this directory. I will show you in the next minutes. Yeah, what we will do, I mean, before importing, we will create new location because I mean the data for the tile, for the selected tile, I mean it's not the data are not referenced in European terrestrial system. So what would happen if we would import Sentinel data in our location? It would be possible, but it would mean that we would perform reprojection of Sentinel scenes from UTM to European terrestrial system. I mean, in some cases it can make, or in some cases it can be fine, but I mean normally you want to use a coordinate system of the scenes you are using if you have one tile. I mean, if you have more tiles which are located in different zones, this is another case. And I mean, what is also important for this workshop, if we do reprojection, it will take some time. So I mean, the import would take a few minutes, maybe more than few minutes on this virtual machine, because GRASS would do reprojection to European terrestrial system. Sentinel products are or the coordinate system which is used for Sentinel products is UTM. So in our case is UTM zone 34. So what we will do, which is also a nice exercise, we will create new location with our target coordinate system UTM zone 32. So let's go back to GRASS and let's try to create new location. You don't need to, I don't know, to quit GRASS and to start from the beginning. Of course, you can create a new location from the current, as we did. So currently we have two locations, right? The default one, which is like a fallback when something bad happened, then GRASS will start to this default location. We have the location which we created for the first workshop, so which is the current location. You can see from, or it's highlighted by bold font. So yeah, so let's create new location. So here by this icon you can create. Of course, there is a tool. There's a command for creating new location, so we can easily create new location. For example, I can show you something more fancy. If for example, I will start GRASS. I will create a location with EPSG code, something really strange like 5514. I will create location in GRASS data, and I will call it like location 1. Okay, I run enter, and I start another session of GRASS, and I got immediately the last the location 1, which is using EPSG code 5514. Or I will close the GRASS. Or I can create a temporal location, and I can run some tools like import data directly into the temporal location. So there are really plenty of options. I want to, yeah. So here is example. So yeah. So I will create the temporal location. It will be EPSG code 4326, and by exec command I will run G region, and I will just print the current computational region. Oh, there's something bad. Box where I have mistake. You see that the location has been created by G region. Yeah, I don't have typo here.
The name is like
Yeah.
location or something.
Sorry,
The one that you created is called location or something like that.
You mean here?
No, before.
Yeah, location one. Yeah. But here I'm creating a temporal location. The location like a temporary location. So this is new location which is created. Just it should run this command, but it's not running. So I will take a look maybe on in the documentation, and I will post command, but it should work. This should work. Okay, I will use existing. I will use existing location. Where is the backspace here? So I will use existing location. So let me try existing location. Yeah, this is typo, but yeah, okay, here I need to, here I need to define also the map set, of course. So permanent. So I have some typo here. So let me check the help. So help will be my friend. Help. I don't see where the problem is. Yeah. So let me check help. Help, and there is exec. There is a space. There is a space. Yeah. So let me check the documentation. There must be some examples. There is something wrong and I cannot see it. It should be explained somewhere. Vero, do you remember the, yeah, I think here. Yeah, here it should be. There should be exec.
I'm also trying myself to see if it
Ah,
works.
okay, I know. I made this mistake in the past, but yeah, this quotes are the bad idea. So you need to define the command which you want to run. Now you will not see, so I will try to enlarge it. So yeah, the command must be run without quotes. Yes. So you see that it created okay, now I am using the existing location and map set, and in this permanent map set in location one, I run a command which prints current computational region, and it will work also with a temporal location. So I will create a temporal location by this. So the location will be deleted afterwards, and here I will specify I want this 44396. Yeah, so it works. I can run like a gproi command, and it will print, yeah, that it's really this location, or it's a correct EPSG code. So there's plenty options. I mean, how to like specify what you want to do from the command line when you start Grass. You can have a script here you specify the exact, can be also the path to the Python script you want to launch. So there are really plenty options how to start Grass. We are starting Grass like using the graphical user interface, but it's good to know that there are plenty options. I mean, which you can use for starting Grass. It's explained here in this startup program. So there are examples. Here's example of the Python script or the shell script. So here is like you use the exec exact parameter. You say that you want to use Python interpreter, and here is the path to the Python script you want to use. You want to launch automatically on startup. Yeah, sure. Yeah. So this is quite common way when you are running Python scripts or shell scripts from the command line on the server. For example, you just log in and you just type the grass command path to your location, and by the exact parameter you define what you want to do. Or you create a temporal location, you run the script. There's the script will compute something, will store the result somewhere, and then it will the grass will delete the temporal location, and that's all. This is basically how processing in Vue.js works, because if you run grass tools from Vue.js processing environment, Vue.js is creating a temporal location somewhere in a temporary space. Vue.js takes the input data, import them into the temporal location, performs the computation, export from temporary location the data, like export it to GeoTIFFs or GeoPackage, and then it deletes, or Vue.js deletes this temporary location. So yeah, there are plenty of options. I mean, here we are just using small segment. So let's go back. Okay, so yeah, now we would like to create new locations, right? Because the Sentinel data, or we want to work with the Sentinel data in the source coordinate system, or the coordinate system which is defined by the Sentinel products, or by the tile which has been selected. So let's create new location. So I will go back to the command line, sorry, graphical user interface, and yeah, we will create location the same way as we did before. So let's define the name of the location. So let's call it ODSE Sentinel 2021. So next, we know the EPSG code. So let's type it. Or of course you could define the coordinate system from the input data. Of course, it could be also possible. So it's 32 4634. It's mentioned here where it says yeah, here, yeah, here. Okay, it's quite normal when there is important word, you overlook it automatically. So you define the EPSG code, you type next. There's something wrong. I hope you should get the parameter, you should get the dialog with transformation parameters or datum transformation, but it's not showing up. This is not good news. I don't know why. It happens once when I was testing, and I needed to kill the GUI because it was frozen. So I'm not sure, it didn't happen on my computer. So I'm not sure if it's related to the VirtualBox or not, but I think it's the case. No, it's just frozen now. Okay, if you have the same issue, don't worry and be happy. Open terminal and type grass. Okay. Yeah. Maybe it was caused. I think the problem was caused by the fact that from the terminal I created new location. Maybe that it's confused now. But if you start grass again, you should get the GUI and environment again, and you should be able to create location. But this is really strange. This is really strange. So I will try to create location again. So I hope that it didn't happen to you. So let's try it again. So let's try. So 4. Wow, there is something wrong. Okay, so well, I tested on my computer, it worked, and I also tested in the VirtualBox, and it also worked. So that's something. It's something new. So I will just stop all grasses which I have. I mean, the most, if you type the, I mean, you can. Is there Mattermost? Maybe I can send. If you, I mean, from the command line, it will work for sure. So where I can write there's Mattermost channel, but Mattermost is where? Here, okay, here. So I need to go to here, right? And here is somewhere town square. Yeah, here. So I hope I will not do the typo. So if you have the same problem, you can create it from the command line. So I hope that there will be no typo. Please check it out. ODSE. Yeah.
Sentinel.
Okay. Yeah. ODSE. Sentinel 2021. How to? Okay. No, it should be like this, right?
You need the EPSG.
Yeah, by C, right? Like this.
EPSG. Yeah.
So 2, 3, 4, 5, something like this, and I think it should be
32, 6, 34. Yes.
I think this is fine. Oh.
Yep.
So this should work.
Yep.
Enter. Okay. Okay, it's a new feeling to be Tom Hengel now, so I need to enjoy it for a while. Okay, let's go back. So I will do the same. So yeah, so C EPSG 32 644 634 grass data ODSE Sentinel. Okay, I have this location already created apparently, so I will just create a new one. Yeah. Okay. At the end, it was not so bad example because, as you can see, I mean, everything what I mean, if you have problem in the GUI, you can always solve it from the command line, which works. Yeah. So that at the end it was maybe good at the end, it was good that we have this complication. Complications are just because that you need to solve them, right? So we have new location for Sentinel data, and now we will try to import our sample data set into the location. So we will use a specialized i.sentinel import tool. We will not use the normal R import, which we used in the first workshop. We will use i.sentinel import. There are other like fancy tools like Sentinel import, which automatically creates a spacetime dataset. When we were preparing this materials, we decided to use i.sentinel because, I mean, from educational point of view, it's better because we will show you how to create a spacetime dataset, because Sentinel import will create a spacetime dataset automatically, and you will not know how it was created. Yeah, so this is the reason why we are using the original i.sentinel import, because we can show you how to create a spacetime dataset. Again, there is a similar flag like for a download, because, I mean, imagine that you have hundreds of scenes and you want to import only selected bands to the grass or link. It's possible. You need to define the pattern, the parameter which is called pattern. By this you can filter for import just selected bands. And of course, it makes sense to first try if the filter works. So there is a P flag like print, not L flag like list, but P flag like print, to test if your filter works. So let's try to run it. So I go to console and I type i.sentinel. Now you see that the graph, because I started again, now you see that the grass knows about the tool. If you don't see it, just type it like a full name and it will work. So here we provide, you can provide path which is pointing to the safe directory. You can download one scene, you can unzip it, and you can point to the one scene. But normally you point to the directory where you have multiple scenes downloaded, which is our case. As I explained, because we removed a few bands, we unzip it. But normally you have in the directory zip files which were downloaded by i.sentinel download. So it's automated workflow. You download the data to the target directory, and then when calling i.sentinel import, you define as the input directory the directory where you downloaded data, and there's no need to unzip or to do some magic. It's automated. In our case, I will go to ODS work there. I go to grass GIS data, the zip file we downloaded, and here geodata, and here's the directory with our Sentinel scenes. So I choose this. So there are 3 scenes, but I mean, it would be nice to have more, but I mean, for a multi-temporal processing, 3 is enough. It's not, I mean, it's minimum, but I mean, we wanted to avoid that the sample data set will be too big. Okay, so, but I will not run it, because first I want to check what is inside, how many bands, what is content. So I go to print, and I will here set up the P flag. Maybe this is good to explain that, I mean, normally if you follow grass documentation, There are not so many screenshots like the GUI, because GUI change, and what is stable mature are the either tools parameters. I mean, grass is not changing name of the parameter. That there is, I mean, there is a backward compatibility only when the major version change. So grass 7 and grass 8 can differ a little bit. There, I mean, the tools can have different options, but I mean, you can be sure if you are using grass 7, then I mean, it will not change in grass 7. It's the important is a backward or the compatibility in a major, speaking from major version point of view, let's say. So you write a script and you can be sure that it will run in 7.0, it will run in 7.6 or 8. And yeah, these okay, back to the documentation. Usually there are commands like for the command line, but I mean the name of the parameters or the flags, you can easily see. If I go back to the GUI, you see the P flag. It's written here in the brackets. Here is the input parameter. So if you are following the commands from some documentation or some tutorial, and you want to use graphical user interface, you can easily construct the command. It's connected. So P flag, and here I set up I choose the directory from our sample data set. So if I run command, it will scan the directory and it prints all relevant bands. Yeah, so of course, I mean, if you have hundreds of scenes, it doesn't make so much sense because you will get a really large list. Here you see that we removed bands in 10 meters resolution. We just kept 20 and 60 meters, and we kept only band 2, 4, 3, and 8A. Yeah, so let's try to filter. So I go to filter. Here is pattern, and I will try to set up the filter. So we want to import. Let's start with something easy. Let's filter only band 4. So yeah, where it is here. So band 0.4, and okay, I want it in only in 20 meters. So I type this. I hope I didn't. Yeah, I made a mistake. There is no underscore between B and yeah, it should be like this. So yeah, you see that filter works. I have 3 scenes, so I'm getting, and the 4B is available only in 20 meters resolution. So I'm getting three layers. So in this way, you can, I mean, try to imagine that you have hundreds of scenes, and you want just to import band 4 and band 8 because you want to compute Ndvi. So don't import everything, just import the bands you want to use. Okay, we will compute Ndvi as just a small exercise. So we will need band 4 and band 8. I mean, because we deleted the bands in 10 meters resolution, instead of 8 band, we will use 8A, which is, I mean, possible. So we want to filter the 4 band, and where's the pipe here, and 8A. I have a typo here, so let me write it again. Still fighting with the keyboard. So yeah, like this. So I will just check. Yeah, it's the filter can look like this. So you select either band 4 or band 8, and you define that you want to filter only bands in 20 meters resolution. Yeah, so let's go back, run, and you should get like a six bands. Yeah, 6 items here. So from this data set, we just selected bands we want to import. So when you check the filter, I mean the way how to work with the tool is similar to iSentinel download. Yeah, first you check your filter, and if you and when you are sure that it's fine, the filter is doing exactly the same you want, then you run download. So here, if you do filtering, it's better to test it, but sometimes you want to import everything, so you just import. Yeah, so this is the first thing. So filtering, and I need to speed up. Time is running again. Yeah, so I will use also the L flag and C flag. Why? L flag is for linking, so the data will be not imported into GRASS, like converted to the native GRASS format. The GRASS will just create links to original files. Yeah, so the GRASS will read original JPEG 2000 files, which are provided by Sentinel products. And C flag means that you will also import the cloud mask. Originally, GRASS imported the cloud mask, which is part of Sentinel product, but with a new version of this tool, the Sentinel import is calling GRASS module Sentinel mask to produce cloud mask, which is better quality than the mask which is provided by Sentinel products. But I mean, if you have fmask, for example, installed, you can create a cloud mask also using fmask library or other tools you are used to. So yeah, so let's go back, and yeah, so you go to print, to tab, and you remove the print flag because you don't want to print, you want to import. Yeah, you tested your filter, you are sure that it's working, it's working well, and now it's time to import. I go to settings, and I will enable L flag, which is the second here, L flag. So link raster data instead of importing. So feel free to link them. You save space on the disk, and I mean GRASS will be still happy. And here the C flag import cloud mask. You can also create a cloud shadow mask. Yeah, there are different possibilities. Yeah, so by this, okay, so we have L flag, C flag. We defined the input directory where our data are located, and by the pattern, we defined, okay, I don't want to import all bands. I want to import only the 4th band and the 8th band. So now it's time to run. So it will take some time. So now the data are imported or linked, and now the second step is performed. GRASS is computing cloud masks using i.sentinel mask module. So it will also take some time. And this C flag, of course, then import is slower because you are computing cloud mask. It's not about importing cloud mask, it's really about creating cloud mask. So it took like almost 2 minutes on this computer. So let's go back to the data tab. And now this is nice. I was explaining that sometimes the data catalog need to be refreshed because I mean, apparently the data catalog is not aware of i.sentinel import. So first you can refresh the whole tree, but it means that it will scan all locations in your GRASS data directory, or you choose the second icon, which scans only the current map set, which is, I mean, better. So if I just, yeah, so you see that there are like six raster layers or maps created. We have 3 bands. Sorry, we have 3 scenes. We imported 2 bands, so six raster maps layers were created, and here is the cloud mask. So let's try to display the first band. Well, it's a little bit disappointing because I mean the grayscale is not enhanced. So let's do it. I mean, GRASS usually not performing these operations automatically. You need to perform them on your own. So how to do it? I mean, how to set up the color table, you know, how to set up by our colors module. What is important if you are doing or if you apply enhancement, the enhancement is I mean, you need to read the raster data to perform histogram enhancement. So then you need to remember GRASS compute, or you need to remember that you need to set up a computation region. So I mean, if you use the static color tables like elevation, Ndvi, it's just applying rules. But if you are performing, I mean, the color table will be enhanced from the data itself. You need to set up the computation region before you enhance the color table, of course. So I will set up the computation region from the scene, and let's do it only once, because I mean, all the scenes we are using one tile. So we set up the color, we set up the computation region now, and then you don't need to care. So let's go to set color table, which is the R colors module. Let's go to define, and here let's choose gray, but gray AQ, which is, I mean, the which is basically histogram equalization. So run. It will take some time because GRASS will read the whole data, and it will perform equalization. So now you see, well, here are the ocean, and so on. So maybe let's copy from our location. In the first workshop we created this buffer around the selected tile, and we pretend that this is our area of interest. So maybe let's compute Ndvi only in this area of interest. We will be not computing Ndvi for the whole image. We will just compute it for our region of interest. So let's go to the data, and we can again to remember how to copy layers across locations. So I will choose the first location here. Yeah, this is nice example why it's, or maybe it's good to mention why it's gray. It's also described here. It's in use. It means that there is a user who is inside. It's related to the fact that the grass was frozen and I kill it. So grass has still lock inside. In this case, I mean, in the case that you are sure that, I mean, there is nobody else, it's just the error, or I mean, it's the case that, I mean, you needed to close the grass incorrectly, then of course there is a way how to break the lock. But I mean, we don't need to break the lock because we will not set up this map set as the current. We just want to copy. So we take this tile 55606. I will take it and I will copy to the current location. Yeah, I will display it. Yeah. So let's change the computational region based on the imported file, and let's align. This is important. I was explaining this in the first workshop. When you setting up the computation region based on the vector layer, then you need to align it to the input raster data which you want to use. Yeah. So basically, we will produce Ndvi here. So let's compute Ndvi, and unfortunately time is running. So I will quickly import. I will quickly create the Ndvi, and I will show you what is important, how to work with multi-temporal data. So I will create Ndvi. So I will use the EVI module. It's explained in online materials, so you can reproduce it. I will choose the 4-band. Okay. The output is Ndvi. Inputs the red channel. The red channel is a 4-band. Near infrared channel will be the 8A band. Yeah. So that's all. So by this module, you can easily compute Ndvi. So you see that here, Ndvi is computed. It would be nice to have like a vector map with the coastline, and it would be nice to mask the ocean, because you will see in August the ocean will pretend that there's a vegetation. There is, but I mean it's still ocean. So it would be nice to have the mask, but anyway, let's continue and let's show how to use these fancy temporal tools in GRASS. So GRASS is supporting temporal data processing. There are special types data sets, which is called the Spacetime dataset. GRASS is supporting raster data, 3D raster data, and vector data. So if you have a time series of raster data or 3D raster data or vector data, you can process it by the T modules in GRASS. So let's create a Spacetime dataset. Or normally you create a Spacetime dataset empty by T create, And then by T register, I forgot about one important thing. I will need to run i.sentinel import again because I didn't produce something important which need to be which is required for Spacetime dataset. So let's go back to i.sentinel here. Okay, I will run again. Where is the import here? So let's do it again. Let's do it again. So grass data here, the filter. Settings, link, see, and what we forgot, I think it's in optional. There is important parameter which is called register output here, because when you created Spacetime dataset, you want to register data into the Spacetime dataset. There are multiple or there are more approaches how to do it, but normally the most easy is that you have a text file which contains the name of the raster file and the timestamp. You can use the timestamps which are part of the metadata, but this is maybe this is recommended way. And I mean, this text file with the timestamps, the module i.sentinel import can produce it, but you need to tell it. And this is the reason why probably the colleagues from Mundialis, they created a t-sentinel import, because it's doing these steps automatically and you don't need to care. So yeah, so here you specify some text files. So I will create like sentinel timestamps txt. So yeah, and I will not set up the override flag, because I mean, now Grass will warn me that the data are already there, but I think it will end up with the error. Yeah, but okay. But still, if you ignore these errors, it's now good idea because the data are there. So we will not overwrite it because it will take another 2 minutes. But the important is that even you don't overwrite the files or the raster files in your location, this text file is created. So let's check it. So if I go to here is the Sentinel timestamps, and here is a simple file, like a CSV file, and you have 3 columns. You have the name of the raster layer. You have the timestamp, which was read from the metadata, and you have a band identifier. This is something new in Grass 8. It's a new feature in Grass 8, and this band references you can use for all on-the-fly filtering. I will show you later. In 10 minutes, in the worst, I mean, we have 10 minutes, 12 minutes. So this is important file. Yeah. So let's create Spacetime dataset. So I will call t-create command. Yeah, here. And yeah, you need to fill some mandatory parameters. So the name. So I will call it sen _ tile _ 560 sen2. Okay, I will be okay. Less typing, more time. Sen2. Okay. This I will skip. I will keep the mean parameter. It's not important in our case. You need to set up some title and description. So yeah, send to data, and here I will write send to tile 5606, something what you want. This is just metadata. Important is the name. So I will create a data set which will be named S2. It's quick because I mean the command just creates empty the spacetime data set. Now we register these six raster bands into the spacetime dataset, and for registering, we will use the text file which was produced by i.sentinel import. And I mean, usually you have not 6 items, you have hundreds of items or thousands. So here input is the data sets which I created. So S2. You can by hand, you can put all the layers, but I mean, this is not the way, of course, because usually you work with a large amount of data. So you create this text file and you just pass it. So here is the file. So I just point the file to the Sentinel timestamp, and that's all. So here I set up the name and the name of the spacetime dataset, and here's the text file with the timestamps. Okay, it's done. So now let's create. We have the spacetime dataset, and let's check the metadata. So we will use tinfo command to understand what is inside of the spacetime dataset. If I mean we correctly registered maps into the spacetime dataset. Okay. No, another grass I don't need. Okay. So I go back here. This I will close. So tinfo. Now you see that I'm not using the module tab because I know how the modules call how the modules are called. So I'm just directly typing to console. So here I will just choose S2 and I run. This is just printing metadata. So you see that here is the spatial extent of the data set. Here is the time extent. That I mean we have not so many bands. We have only three scenes. So the first scene is from June, the second scene is from July, and the last scene is from the end of August. Here you see the statistics, minimum, maximum values, and here it's important. Here is the number of raster layers which are registered, so 6, and number of bands. It means that we have only 4 and 8 bands. Yeah. Okay, so it seems to be correct. We are satisfied. By the T-Rust list, you can print the content of the spacetime data set. You can use some var statements. You can print only data in the given time window, and so on. So there's plenty of options, but unfortunately we don't have time for that. What I wanted to show you is how to compute Ndvi using spacetime dataset. There are 2 options, at least 2 options. One is, let's say, traditional. It will work. It will work also in Grass 7. In Grass 8, there is a shortcut. So let's explain. So here in a let's say, if I would not use new feature with related to band references in Grass 8, in Grass 7 I would use a T-Rust extract. So I would extract from the spacetime dataset only the fourth band. So here I am using basically SQL statement. I'm telling, okay, I want to extract from this spacetime dataset only raster layers which have B04 in the name. So I'm relying on the name, which is not so safe, you know, but it's working because it's automated. The names are set up from the file name. So I mean, if there is a B04 in the file name, it's band 4. So it works, but of course, relying on the file name is not perfect solution, but it works. So basically, you created 2 new spacetime dataset. One contain only the band 4, and one contain only band 8. So I will just copy paste this, or maybe I will explain the new. So you will get 2 new dataset which contains only B4 and B8, and then you run a TRAST algebra. Here you specify the expression for computing Ndvi, and here you are basically passing name of the spacetime dataset. Yeah, so it will create, we have 3 scenes, so the result will be 3 Ndvi products, one for June, one for July, and one for August. So because we are working with a multi-temporal data, TRAST algebra finds for the band 4, I mean the band 4 June, it will find the corresponding band 8 in June, the same timestamp. So this works. It will create a new spacetime dataset, which is called, in this case, Ndvi. And in this new spacetime dataset, new Ndvi products will be registered. So this is like a traditional way how to do. With the band references in GRASS8, it's a little bit easier because you can filter directly bands from existing spacetime dataset. So you don't need to create a new dataset by TRAST extract. You just use the input, or you use the dataset with all bands, and by the band identifier, you just on the fly filter from the spacetime dataset relevant band. So S2 underscore 8A filters 8A band. S2 underscore 4 will filter S2, like Sentinel-2 will filter the 4 band. And here is the same expression. It's a little bit longer, but I mean, you don't need to create separated data set. You just run it on the fly. So let's try it. I just call the dataset differently. So I will just copy paste this part because I don't want to write it. We have 2 minutes. So TRAST mapcal. So here I will write S2 dot. This is the name of the spacetime dataset which I created. So first extraction which will be created on the fly is S2 dot S2 4. I think it must be uppercase. So I will try to be on the safe side, and I will use uppercase. S2 S2 B8A. So here you specify the extraction which will be created on the fly. And I will here copy paste. I just need to fix the name. So the data set is called S2. Okay. So the name of the output, this spacetime dataset Ndvi, and yeah, it will produce new raster layers. So you need to specify the base name. So I will call it the same Ndvi. So it will create like a Ndvi1, Ndvi2, Ndvi3 with the correct timestamp, of course. So let's run it. Yeah, you can also, I mean, this is important. Most of T commands have a nproc, or you can define how many cores you want to use. I mean, you can perform computation in parallel. Of course, this is the important thing. So yeah, I'm not sure how many cores I have here, so I will type 2. Okay. So I run it. Yeah, Ndvi exists. Yeah. So I will, because I created Ndvi map already. So I will call it like Ndvit. Yeah, so I will use the same name for the spacetime dataset and same name for the basetime to make it easier and more understandable. So run. Ay. Well, so yeah, what is it? It should work. So I have some typo, hopefully, because it worked. No idea what is wrong now, and there is no time. So maybe I will use a traditional approach. But yeah, I tested on my computer, I tested in virtual machine, and it worked. So I have probably some typo, but I am really not sure where. Here. And the error is misleading. Yeah. So I have here typo.
The band forest.
Yeah. The B is the typo, but we need to fix the error message because it's not saying anything useful. So I have
it's
typo
really
here.
frightening indeed.
Yeah. So fingers crossed now. If you can pray, please pray. I cannot, but so it's up to you. Thanks for support. It finished. So let's check. So if you just refresh the data catalog, you should get new 3 layers: Ndvi T1, Ndvi T2, Ndvi T3. Yeah. So let's display it, and we are running out of the time. So give me like 2 minutes just to finish it. So yeah. So let's display manually the first. So this will be from June. The color table is not so fancy, so let's fix it. There is a RR raster module, right? And I mean, most T commands mimic the original command. So there is a TRAST color module which calls color for all layers which are registered in the spacetime dataset. So here I will choose spacetime dataset and I will define the color table. Not the bear. Okay, I will write it by hand. Ndvi. Okay, if I re-render, I'm getting. So this is June. This is July, and this is yeah. You see that in August the ocean is starting to be green a little bit. If I just show the metadata, you see that in metadata, there is a timestamp correctly set up. So of course, Ndvi T1 has a correct timestamp. So it's a 24th of June 2021. So yeah, so in this way, you can create Grass has like a tools for animation. Then here is just really shortly because it's time to finish. You can here you can see how, for example, okay, there's example of the Python script which also applies the cloud mask on the time series data. So you are producing Ndvi products which are masked. I mean, Greece, there are not so many clouds, so it's not so visible. There are small holes here is the one small cloud located. So yeah, so you can follow what is written here and you can try it out. The last unit is about how to use a Python Temporal Api. That I mean, the TRAS modules are basically Python modules which were designed by the temporal or Python API, which is suited for temporal processing. So here's example. I just the workflow is just reclassifying Ndvi to 3 classes. So you are getting, and some, yeah, there is some post processing that I am removing the small classes here, and the script, which is like the result of this unit. It's using a Python Temporal API. So here is highlighted that I mean, using this Python code, you can get all layers which are registered in B4 Spacetime dataset and so on. Here you can sample Spacetime dataset just to like combine layers with the same timestamp from different Spacetime datasets. So there's plenty of options. I mean, the script is also printing some statistics, how I mean, for each class, here it's computed the area occupied by the class. The numbers are a little bit, I mean, what is needed here, and it could be task for you to apply mask, which is based on the coastline, because I mean, it would be really good idea to mask ocean, of course, because then you are getting strange numbers here, of course. Okay, so sorry for delay. It's a lot of stuff, and it was just the introduction. So Grass offers a lot of tools, a lot of possibilities to work with raster data, vector data, 3D raster data, and also space-time data. There are spatialized tools. Maybe last thing which I will show. Yeah. I will check. So if I just run this T dot, there are commands which are designed to work with a space-time data set, and there are other tools available in add-ons. So let's check the chat. Okay, thanks for comment, Vero. I think Vero explained a lot of or answered a lot of questions. Thanks for that. So I think it's done by Vero. So thanks a lot, Vero, for support. Okay, if you have any question, please write to Grass mailing list. There's a lot of people who will be willing to answer you. So thanks for attention. Yeah, could be also possible. Okay, so Thanks. Thanks. Yeah, please. To you.
Tutorials online on our GitLab, so you can access tutorials, and you can see the notebooks, computational notebooks. So you should be able to repeat lots of the analysis yourself. Thank you for your participation, and we stay in touch. Connect tomorrow with us. We are again live starting from morning 9